Hi everybody, Dr. Pingel here, recording this on February 11th. This is an asynchronous lab meeting. This is actually the second time I'm recording this. The audio didn't record the first time through, so we'll just get right underway here. The first thing is that I noticed that the gimbal control stick on the Mavic controller is broken. This is a bummer, I guess. Now at this point, I've checked with Jack, and he said it was broken when he got it. So we'll have to try to figure out what might have happened to this. I don't know. I think we could replace this controller. It's probably not a critical thing for what we do, but it's a bit of a bummer. Yeah. There's a CNRE career fair coming up on February 22nd. If people have, people are going to be graduating soon, and actually I would say that this isn't just for seniors. This is for everyone. So please consider going to this. This is a really great event. Career fairs help you network. They help you find a job. But I think one of the great things to do is to go to these when you're, freshman, sophomore, junior, because you get a chance to sort of see what these things are all about, and potentially establish ties that you can use later on. I've got the Mavic 2 Pro model, camera model calibrated. This was a bit of a difficult. I probably should have plugged my phone into the controller to do the heads-up video, because as it was, the pictures were just a little bit further away than I had intended. I sort of had to just make a guess, and they're a little bit further away. But I think it probably calibrated fine. So that's these have been posted. These have been posted to the GitHub page and linked. They ended up not being so different than what we had before. It was about 2% different than the default. Even so, I think that's not a bad improvement. 2% is still kind of a lot. Things that are sort of under 1%, half a percent, that's pretty close. But 2% is kind of a lot. Tim Baird forwarded this to me related to the Build project. That's kind of the indoor people tracking stuff that I'm working on. This is a group here at Virginia Tech that made these sensors called the Building Data Lite. It's built on the Raspberry Pi platform, integrates temperature, humidity, a couple of other sensors, and outputs the display to a screen. These are pretty cool. I would love to build one of these. I think that this looks like a lot of fun. Those of you who are in my geovisualization class, this is a bit of a peek under the hood. I'll be talking a little bit about balance and showing this example. This comes from Terry Slocum's geovisualization book, and on the left is a map that's kind of unbalanced. The title is kind of crowded in there, and the legend and the scale bar are both at left, and it kind of crowds that side, and then the lower right hand side is just kind of blank, and that leads to an unbalanced look. And I wondered if you could just sort of do something as simple as calculate the center of mass on the image, where the pixel weight is essentially the lightness or darkness, and maybe that's not the best way to measure it, but it turns out that ND image, which is in SciPy, has a center of mass function, very easy to calculate. I played around with it a bit. It didn't work quite as well as I thought. So the red dot is indicating center of mass. You can see that the one on the left is indeed a little bit further away from the center than the one at the right. But what's interesting is that I think what's happening is the legend, when moved over, really helps balance it more than the pixel weights from the text would indicate. So I think there's a Gestalt thing going on here where basically that whole thing is treated as an object, and that's what sort of pulls the weight back where it should go. I think it would be interesting to test this out. I did try some simple morphological operations, binary thresholdings, adding some exponents to sort of change the weight scale. None of it really quite did what I wanted it to do, but it was a good sort of first cut at it, and maybe this is something that I'll take a look at later on down the road. Lynn Resler's data is complete. That took about 12 days to run. It's 11 projects, 90 gigabytes of data, 100 million some plots per plot, or points per plot. And I wanted to give a shout out to Barrett, who helped get this analysis started. So Colleen sent this to me maybe about 2 weeks ago during a lab meeting, or no, an individual meeting. And this is a paper by Dominika Ciskowska and colleagues about a LiDAR scan of Machu Picchu. So the left paper essentially brought me to the right paper, which is the second author on that other paper. And the rightmost paper really describes sort of the LiDAR system, and this is what it looks like. There's a typo here. This is actually a $20,000 build of a LiDAR system, which is pretty cool. You know, I'm interested. We have many of these components. We probably could put something like this together. I don't know how well it works, but anyway, this is a pretty neat application of mobile LiDAR scanning, and I emailed them to ask if they would be willing to share both the LiDAR data that they collected from their drone and the archaeological LiDAR data that they compared it to. So this is the first that I had seen that Machu Picchu had been scanned with LiDAR. Totally makes sense, but it would be awesome to get a copy of that. I guess I strongly suspect that they probably won't share either of those two data sets, because they probably have a lot more stuff they want to publish on this. But I did offer to, you know, trade favors. I'd be happy to help them, you know, process their LiDAR data if they had any interest in that. We'll see what happens. No word yet. One of the things in that paper, though, that I thought was interesting was they've got this map, which is, unfortunately, this is as clear as it gets. Not a good high-resolution copy in the document itself. But there's Machu Picchu up in the upper kind of left-hand corner, and then the river that kind of runs around it. And of course, this is up in the Andes in Peru. And the neat thing about this is, they have a pretty nice high density of sites, which is higher density than I think we've seen. Certainly, some of these things Colleen had collected before, but some were new. And then the density of the trail network here is quite good. So some of these Inca roads were not in the Smithsonian data set that we got. So I thought this would be a fun chance to sort of see on a very localized scale right next to Machu Picchu. And so I ran it through the scripts that Colleen and I have been developing. And this is what you get. This, you know, these are, forgive the cartography here, this is just exploratory data analysis, so it didn't bother me. The colors are terrible, whatever. Anyway, this is, you know, you can sort of see the tracks overlay from both the aerial and linear routes, and then there's 4 different ways of doing it, so there's 8 total tracks here. And overall, this set, I think, does a fairly good job. There's a couple of interesting departures, and those are instructive routes that sort of get missed in very particular ways. But overall, I think there's an okay correspondence here between what we're seeing here and the routes on the ground. And then this is really of interest to Jack and Johanna. We've been talking a lot about camera calibration. I have over the last year and a half. It's one of the kind of frustrating parts about working with structure from motion data. You have to have a good mathematical model of the camera to do a good reconstruction. And part of the deal when you run the software is that it tries to figure that out for you. But alternatively, you can calibrate the camera ahead of time. One of the things that you have to know, though, is the pixel size of the sensor itself. So how big that little receptor is in microns on the little chip that the light shines on. So there's a lot of uncertainty on the Mavic camera, on the Hero 9 camera. Johanna will probably talk about this, but she heard from GoPro that they aren't even allowed to tell us what that number is, which is wild to me. But anyway, so the one way to try to figure this out, I think I had talked about the Hero 9. There are sort of 9 plausible guesses about what that sensor size might be. But with the Hero 4, which is what I'm showing here, I had collected some data at NIU campus, and that sensor has pixel sizes of 1.55 microns, and I think we pretty well know that that's what it is. So what I did was I ran a Pix4D run with the default camera settings and let the camera calibrate. There's a really nice differentiated area, so it reconstructs quite well. There's a lot of buildings and a lot of edges, and you know, these are some of the first structure from motion models that I ever built. And it turns out that these are about as easy as it gets. This level of differentiation makes life easy. So I did that, and then I cranked the pixel size down to, I think, 1, and then I cranked it all the way up, I think initially to 2.5 or 3, and I didn't see any differences, and I ended up cranking it all the way to 10 microns, which is preposterously big, and I ended up getting no differences in any other reconstructions. So that's a bit of a mystery. I'm very surprised that that's the case. I'm not quite sure what accounts for that. Yeah, but I guess it doesn't matter. The good news is that I think we can proceed with any of the camera models for the Hero 9 that we have, and I did calibrate the Mavic, as you saw earlier, and so I think we can just use those calibrations, and we're going to be in relatively good shape. I don't really have any explanation why that should turn out to be the same. I would have thought that was a very critical parameter to get right. So strange. So these are the goals, sort of an aggregation of some previous goals and next week's goals, basically anything that's not done this week. I wanted to build the lab's Hexoon 450. That is now done. So thanks again to Cameron and Andrea for helping with that. We were really just like a half hour away from finishing that other Tuesday. So I taped on the components and I ran just a couple of calibrations, the accelerometer calibrations, which take another minute, the compass calibrations, which take another minute, and setting the failsafe on the radio so that if the communications get disrupted, then it is still good to fly. So now we've got liftoff. I would show you this video. I posted it to Slack. This is the Hexoon taking off in the lab for just a second and then landing back down. We've still got some work to do, but I think it is now ready. There's an auto calibration that needs to happen and just some flight tests. We also need to register it with the FAA and register it with the school to make sure that we've got the insurance for it covered. And otherwise, I think we're pretty good to go. So exciting to have this in there. There's some redesigned components that I want to do. I want to build sort of a top shell for it that'll hide everything else, and then the GPS can actually sit on that top shell. I think that'll be a fine system. I want to make a mount that can hold a camera, because we don't have a way to do that yet. So that should just be a quick 3D printing job, I would think. But nearly ready to go. In fact, I've got cameras that'll fly. I've got things that'll sort of allow us to fly the GoPros, but we would need to gin something up to fly the FLIR camera. I've prepped Jack's data set for the undergraduate researchers. They've all been working on sort of mastering Pix4D, and then next week they'll get their first assignment. Remember that our lab meeting is going to be Tuesday on Zoom, and I will remind everybody via Slack. But one of the things that I'll be doing is sort of doling out those little projects to everyone, and then they can start contributing to that analysis, and that'll be really useful and helpful. Jack and Johanna and I outlined the spring structure for motion study. It turns out that we're probably not going to be doing a lot of empirical data acquisition like we were thinking. We've got enough other stuff that I think we can talk about, and so the paper we're planning on would just get a little overloaded if we tried to do that. But we are good to go there, and then we're going to take a few weeks off while we all focus on a couple of other things and get back to it, I guess, mid to late March. I did some of these. I applied some of the camera calibrations to both Jack's data and the Wong Park data. I don't know yet how much it matters. The Wong Park data, I think the conclusion is that it was really hard to tell the difference. Jack's data, yeah, I don't know that it's solving the problem, but I'm still glad that I did it. I completed the IRB training, so this is the Institutional Review Board, and their job is to sort of make sure that any studies working with people are safe and well justified. This is for Gunjan's study, but since I'm the PI, because I'm a faculty member, I also need to complete that training, which is now done. I actually had I think it was still current from a previous one, but I just did it again to make the logs obvious. There was some kind of data lost at some point. Anyway, I've finished analyzing Lynn Resler's data sets. We've got the undergraduates started on projects. We're going to expand on that next week, and then I think by next week we'll be pretty well humming along, and everyone will have something in particular that they're working on. I want to get the posters started. We need to lay out topics, but I talked to Chandler, and Chandler's going to help design a sort of a common format for the lab, which I'm really excited about. And then we got liftoff with one of the Hexoon 450s. I guess technically they've both lifted off, but mine got parted out again, and I need to do some soldering. So repair my Hexoon is still in red. I lost the power distribution model, and it turned out to be right in a bag, right where I should have seen it the first day, but I didn't see it. So anyway, still got to do that. I want to find people to work with LiDAR with Shashank. He's been trained up on the Livox scanner now and knows how to do it, and I want him to teach a couple of the undergrads how to do it so we can get you guys out there collecting data. And then I really want to flight test my Hexoon, weather permitting. I still don't think I'm going to get to do it this weekend, but maybe next week. So that's it for me. Short and sweet. I think the re-record ended up shaving 8 minutes off of this thing, so that's good for everyone. Have a nice weekend, everyone. Sorry we couldn't make it today, but we'll see you back next week. Bye.